In this video, we will look at the basic process of driving this Abrams tank. In this driver's section, he operates the handles like a motorcycle sticks with 2 throttle. We will also be looking at how the trophy system works, which is being borrowed from the Merkava tank. And most importantly, the basic process of how the gunner operates the Cadillac sticks to fire the gun. Keeping in mind, this video is a correction from a recent video on the Abrams tanks. Giving due credit to our audience for helping us correct the mistakes all in the videos ahead. The driver usually enters through this hatch. Because of the small size of the tank, the driver gets the lazy chair. This is the brake pedal, and interestingly, it does not have steering like the Leopard tank, as animated in our recent video. This is how it works. The driver turns the tank by moving the handle like a motorcycle. In order to move the tank, the driver twists the throttles towards him. Unlike a motorcycle, the throttles are not independent of each other, they rotate together. To turn left, the driver turns the steering to the left. This increases the speed on the right sockets and tracks. As a result, this helps turn the tank to the left. To turn the tank to the right, the driver turns the steering to the right. This increases the speed on the left sockets and tracks, which helps turn the tank to the right. Let's look at the different version to help you understand better. This is the M60A3 patent, built in the 1970s. It was the main reason the M1 Abrams line of tanks was built. This is the M1A1 tank in service with U.S. Army in 1986. Moving to the sides is the M1A2, and this is the M1A2C. This mine-clearing plow could also be fitted to both the version, which was one of the main demands in urban warfare. Interestingly, this is also similar to this Leopard 2 tanks, as they both came from this joint MBT program animated in our recent video. Anyways, enough history lessons, let's get straight to the basic engineering behind it. We will be looking at this M1A2C Abrams with Tusk. Its full form is Tank Urban Survivability Kit. This tank commands a length of 9.83 meters or 32 feet long. The width of this tank is at around 3.66 meters or 12 feet, while considering the Tusk 2 edition is around 4.34 meters or 14.2 feet. The height of this tank is around 2.95 meters or 9.7 feet. It has a combat weight of 61 tons, making it one of the heaviest tanks in the world, just behind this Argent MBT. Let's compare this to a person to understand its size, even better compared with the German Leopard tank and the Russian T-90. The Russian T-90 was intentionally made to have a lower profile than our Western tanks, all at a cost of around $4 million. The Leopard was made at a cost of around $7 million. And top place goes to our American tank, the Abrams, at $8 to $10 million, with all the added features of Tank Urban Survivability Kit. The Abrams has a crew of 4, a commander sitting almost at the top center. To the left sits the gunner, just below the commander. Moving to the extreme right is the loader, and the last crew member is the driver. Let's start from the front. This is the 120mm smoothbore gun. Just beside it is the coaxial machine gun on the Abrams. Moving further, this is the counter-sniper or anti-material mount that is mainly used by the gunner for any infantry attacks. This is the gunner's primary sight with the ballistic shield cover. Let's move further to the back. This is the 50 caliber machine gun to be operated remotely by the commander. Moving to the side, this is the commander independent thermal viewer. Let's move to the interior of the tank, where we will find the commander weapon station. The main protruding object is the primary sight extension that makes sure that both the commander and the gunner are both on the same page. Moving to the side is the commander display unit, while just below is the imaging system. This is the commander control system that tracks the target with the panoramic 360-degree sights and moves just like the animation shown here. Using the panoramic sights, the commander tracks the target and sends the data to the gunner to fire the gun. Moving to the side is the CROW, or in full form, Common Remotely Operated Weapon Station. This animation shows the commander can remotely operate the 50 caliber gun from inside the tank. Let's look at the gunner station. This is called gunner Cadillacs. Specifically, the two black handles are the controls. The smaller red switch above is, of course, the trigger. Pressing that switch with both safeties disabled, this 120mm gun unleashes its firepower. Also to be noted, the gunner can use one set of switches on one side of the Cadillac if injured. This big switch, when pressed and held, the gunner can turn the turret, just like the animation shown here. It could also elevate and depress the gun tube when both the switch are pressed and rotated. This is the result when viewed from outside the tank. If the gunner lets go of that switch, the gun will stop moving. This is the blow-off panel, and it is programmed to eject the cover just like this when a round is hit. This is done to direct the explosion upwards, instead towards the crew compartment. Let's go inside the tank and see how this works. This is how he opens the door. Put a knee on this switch here, and pop slides the ammunition compartment door. It could carry different variants like Heat MPT, which is the main round, although it is not as accurate as the M829 series armor-piercing, fin-stabilized, discarding sabot. Just for comparison, this is the size of the round to an average human. When fired, the round reaches the target and detonates, creating a molten metal of hypersonic jet to destroy or penetrate around 600mm of rolled homogeneous armor. This heat round has a range of 2,600 meters or 1.6 miles. Comparing this to the fin-stabilized armor-piercing sabot, it has a range of 3,500 meters or 2.1 miles. Let's look at the major differences between the two. Modern armor-piercing fin-stabilized discarding sabot is designed for one thing only: to kill tanks. While this heat round is not very good against the main battle tank, but good for lightly armored vehicles. Let's see what happens when an armor-piercing fin-stabilized discarding sabot round leaves the protective shells. This might penetrate right through the lightly armored vehicle and pass through them. In short, they have a logistic problem of carrying different rounds for different target. So the Americans developed this multi-purpose round as a solution. The strategy is to replace all the rounds discussed above with just one round. The gunner could program 3 types of ammunition with this multi-purpose round. Number 1. Point detonate is ideal for armored vehicles and trucks. Number 2 is the air bust mode. This is used usually for infantry vehicles. Number 3. Point detonate with delay mode, ideal for tanks and heavily armored vehicles. This is the Merkava tank's countermeasure system, also called the trophy system, which could be upgraded towards the Abrams. The trophy kit extends off the side of the turret, adding almost 2 feet or 600mm to the sides. But interestingly, this cannot be equipped with the Tusk II kit. It is equipped by 4 radars and covers all round 360 degree, and uses a processor and onboard computers to locate and track incoming threats. Let's see how this works. Number 1. Radar detects and classifies incoming targets. Number 2. The system tracks threats, computes intercepts parameters, and transmits alerts to the crew. Number 3. If the threat poses danger, the countermeasure engages to neutralize it away from the protected zone. This usually protects only anti-tank missiles, but is useless against armor-piercing fin-stabilized discarding sabot. To counter those tank rounds, the Americans have a top-secret depleted uranium armor. This is supposedly the location of the DU plates. Let's look at what's inside this depleted uranium composition. This is the outer layer of steel. The middle layer is the depleted uranium, which is 1.6 times as dense as lead. Let's move to the sides. These are the set of explosive M32 reactive armor, which are arranged in tiles. But the American engineers wanted another layer of protection. The result is these curved tiles on top of the boxy ones. When an incoming shell or rocket hits the curved tiles, it slows down and hit the reactive armor blocks with less kinetic energy. They then detonate, helping prevent the projectiles from penetrating into the vehicle and protecting the crew. But the problem is all these additions made the tank heavy and less mobile. So the solution is fitting a gas turbine engine that is light and powerful instead of a diesel engine. This is the AGT 1500 Honeywell, which not only runs on jet fuel, but has a multi-fuel design that can be powered with diesel, marine diesel, or gasoline. So, yes, this is really an advantage on the battlefield. These turbines almost work like a jet plane. Spinning the jet engine generates a lot of heat due to the enclosed structure. So to prevent the engine from overheating, two cooling units are added that sucks hot air from the turbines to reduce the heat signature as much as possible. All that power is transmitted to these sprockets and running gears, which is responsible for moving the tank along with the track wheels. We have to point out the pros and cons of this tank. It has an improved fire control system that allows for faster and more accurate targeting. This tank has the best new thermal imaging system that provides improved night vision capability for battle management. It also has a powerful engine that allows it to reach speeds of up to 45 miles per hour and travels over rough terrain. It has enhanced protection called the Trophy Active Protection System that can intercept incoming anti-tank missiles, and rockets along with the secret depleted uranium armor. Improved firepower, as the 120mm smoothbore gun could fire various shells, including the multi-purpose round and high-explosive rounds. Let's also look at the cons or the disadvantages. Despite its advanced armor protection, the tank is still vulnerable to certain top attacks weapons, such as the Lancet drone. In some studies, it was reported that the Cornet anti-tank missile could also become a threat for the Abrams tanks. It also cost a big $10 million, just for the tank alone, compared to the Russian T-90, which cost only $4.5 million. The Abrams is a large and heavy vehicle. This can make it difficult to transport and operate in certain environments, such as urban areas or areas with narrow roads and bridges. And the last one is the turbine engine, which generates a lot of heat, vulnerable to most infrared search and destroy missiles. Credits to all our supporters who helped us correct the mistakes. Watch out as we bring you the Challenger 2 and the fire and control system behind it. So like and subscribe to help us produce more videos like these.